Okay, welcome to the Dublin Academy of Maths. Okay, so this week we're going to do indices. So it's Junior Cert Higher Maths, Junior Higher Maths, Series 1, and it's Episode 3, and we're doing indices. This is the subject, and it's all about Paper 1. These are the questions you have to do. You have to simplify these after I've shown you the examples. So you can take these down. There's 6, 7, 8, 9, and 10. This is solve for x. Okay, so you're using the indices to solve for x. Now the last day, there was a kind of a, I presumed this, well, I made a error of putting this as 2. Okay, so it was 1. Right, so you multiply them out, plus by minus is a minus, and you add the indices. Okay, so like I said, this is live, or this is, I don't have any editors or expensive equipment, so I'll edit this, but I could, but it would just take too long. Now also this, when we had something similar to this, 14x, and I left it at that, well, you can simplify it that, you should simplify that much further. So you divide, the common divisor would be 7. 7 into 23 goes 3 times. And you would have, you would also divide the x in, and it would give you 2. So the answer would be 3x over 2. Okay? Now, indices. Indices is a lot like algebra. Right, so we've already done types of indices when we're adding indices. Now we remember that when x to the power of 4 times say 2x minus 2x to the power of 3. Now we multiply, of course, minus by minus is a minus by plus is a minus. X cubed plus, you add the powers. 3 and 4 is 7. Okay? Now we've done those before. Now I'm going to give you, and we've done also x to the power of 6, for example, over x to the power of 4. We bring it up and it becomes x to the power of 6 minus 4. Okay, so that's those two rules we've already done. Now a to the power of m to the power of n, for example, x to the power of 2 all to the power of minus 3. So when you have a power to the power, well, we'll just make it a plus, just make it easier. So we multiply. Okay, that's the rule. Multiply the indices. So it's a raising a power by a power. We multiply the indices. Okay, so you can see that it is the power to the power. So that's this first example. The second example is anything to the power of minus n is equal to 1 over a to the power of n. Now that means that if you have x to the power of minus 3, that's equal to 1 over x to the power of 3. If you have okay, so that would be the simplest version I can come up with. Now, and the last one is, no, there's one more. A is equal, anything to the power of 0 is equal to 1. So remember that. So if you've got 253 to the power of 0, you know that the answer is always going to be equal to 1. And if you have x times 253 to the power, the answer is going to be 1 times x. Okay? And the last one, which is quite difficult, I'll just get it up here, and it's the root sign. Okay, so this is the fourth of this type. So a to the power of m over n is equal to the nth root of a to the power of m. Now I think I've done this with you, I might have come across a question with it. For example, let's do a quick example. 27 to the power of 2/3 is equal, we root this, so this becomes the cubed root of 27, all to be squared. The cube root of 27 is, if you use your calculator, you know the function. There's this xy function in your calculator, you better get used to it because you will be asked these, especially in the written ones. So the cube root of 27 is what by what by what will give me 27? The answer is 3. And what by what squared is equal to 9. 3 3 is a 9. Okay? So that's indices in a nutshell, but we will be doing plenty of examples of them. Now, this is an unusual. This is 2 to the power of x is equal to 16. Now we have these down here. The first thing is, this is a equation which must be related. So in other words, they must have the same base. Same base indice. Okay? Same base for the indice. So the same base is 2. I'm picking the lower base. I can't pick 16. So 2 to the power of x. What is 16 to the power of 2? So that's, what's 16? 2 by 2 is 4. You're very careful with 2's because they're so small. And this is 8. So by 4 is 16. 2 2's are 4, 2 4's are 8, 2 8's are 16. Okay? So you be careful with 2. So now I'm going to rewrite this as 2 to the power of 4. Okay, 1, 2, 3, 4. Now, and then I cancel my bases. Alright, because they're equal. They're in the same level field. And x is equal to 4. And you can prove that by putting it back in. And with larger equations, with 2x plus 1, for example. Right? Now that's a pretty basic one, but these are all the same. It's the same base here as 3. What's 1 over 27? 1 over 27 as base to 3. Well, I'll leave you that, because that's quite easy. I'm not going to do that for you. Okay, that's great. Now moving along, I'm going to do a question out of the papers. And I've got question paper 1. We're all doing paper 1. And it's question 1b. And it says, write this in increasing order. 4 to the power of half, 4 to the power of minus 2, and this is year 2013. So this is year 2013, last year. So, and 2 to the power of 0, and 2 to the power of minus 3. Now it says put them in order, increasing order. Okay, well, I have to look at these, and the first thing I do is I try and work with them. So what is 4 equal? 4 to the power of a half. 4 to the power of a half. Well, they're all, the lowest base is 2. So remember, get your base. Okay, so 4 to the power of a half is equal to 2 to the power of 2 to the power of a half. Okay? So 2 to the power of 2 to the power of a half. Right, so square root of 2, so oh, sorry, that went wrong a bit, sorry. That's 4 to the power of a half is the square root of 4. Alright, which is equal to 2. Sorry, I'm not with it at the moment. And 4 to the power of minus 2 is equal to 1 over 4 to the power of 2, which is equal to 1 over 16. 4 by 4 is 16. Now, 2 to the power of 0, anything to the power of 0 is equal to 1. Okay, so I've got 1 here already. So that's the highest one at the moment. But I've got 2 to the power of minus 3 is equal to 1 over 2 to the power of 3, which is 8. So I've got from increasing order. Okay, so from starting from the lowest, so you got 4 minus 2, 4 to the power of minus 2, because it's a 16th. The next one is 4 to the power of minus 2. The next is 16th and 8. And 8 is equivalent to 2 to the power of minus 3. So I'm just going back and looking at my original indices. And so that's 8 and the 16. And what else have I got? So I've got 1, which is 2 to the power of 0. And then the last one, which was 2, which is okay, so that's 4, yeah, that's 2. Okay, 4 to the power of a half is square root of 2. 4, which is 2. So that's my order. It's increasing that way. So the first thing you do when you're giving these questions is, okay, a lot of people stare at them and they say, what am I going to do with these powers? What am I going to do with this one? You have to start dealing with them, put them into the bases, write them down. Once you start writing, the pieces of the puzzle fall into place. Okay? And now I have another one. This is paper 2011, and this is question 1b again. And this says, well, let's have a look at this, by 27 all over 3 squared. Now, and it says, write in the form of 3 to the power of n. Now I can't put this in. Write in the form of that, and n is an element of q. What's q? Q is an irrational number. Q is anything in a fraction form. So how am I going to write this? Right, get the base. What's the basic base here? So I have to represent as 3 to the power of n, remember that. So the first thing is, what is my base? My base is 3. So what's 3? Square root of 3. Square root of 3 is 3 to the power of a half. So I'm getting the first one, I'm getting the same base. Same base. Multiplied by, what's 27 to the power of 3? 3 to the power of 3. 3 by 3 is 9, 3 9s are 27. All over 3 to the power of 2. Okay, now I bring that up and that becomes 3 to the power of minus 2. Right? Okay, so you know what happens here. I'm bringing them up and it changes the sign. changes its function, should I say. Now what do I do here? I have all the same bases, but what am I doing? I'm multiplying here. So what's my rule for multiplication? My rule for multiplication is addition. Okay? Right? It's there. Where is it? It's there. Okay? So I have to add these. So that's a half plus, I'm getting rid of my bases. 3 minus 2. 3 minus 2 is 1. I don't need to go into fractions. So that's a half plus 1 is equal to 1.5. And in the fraction form it says that q is an element of n. Or n is an element of q. Q is an irrational number. They want it in a fraction. What's 1.5 as a fraction? It's not 1.5. It's 3/2. Okay? That's great. Now that's your indices questions done. There's very little indices questions, so I'm not going to spend too much time. That's it, finished for now. I'm going to go work into hopefully functions next. And anyway, good luck with those questions. Thank you. Bye bye.